Hey guys, I'm the 50s Kid. This is a 2004 BMW X3. It's an E83 chassis. We're continuing on with the M54 head gasket replace series, like engine rebuild series. And I've got the head back from the machine shop. We're gonna go over what I had done to it. We're gonna go over some cleaning stuff that you gotta do to the block before you put the head back on. And then we're just gonna get into it and put it all back together. Anyway, let's get started. So like I said, I got the head back from the machine shop and I elected to only have it cleaned. I also took the camshafts and the cam trays along with this. So we just had it cleaned. That's hot tanked. You know, it gets all the gunk off, which is really great. I elected to also do a pressure test on this because of that situation we were seeing with all that pinkish white stuff. I think it was either, a failed automatic transmission cooler, or it was stop leak product of some kind, or ATF fluid poured into the coolant reservoir by mistake, something like that. But just in the case that it was engine oil mixed with coolant, that could have possibly happened if one of the cooling channels was cracked and was leaking over to one of the oil channels. So I had the thing pressure tested. So that was another 50 bucks. So the cleaning was 50 bucks, pressure test was 50 bucks. Pressure test came out okay. It's a good head to use. I didn't have them resurface it because it's flat. The machinist, he was upset with me. He really wanted to resurface it. And in fact, he was showing, he had his straight edge, across on the diagonal. He was kind of scraping a little bit, and he was showing how he could put a little scrape right out at the edge and stuff. That's fine, and I understand, and he's right in that respect, and I probably should have had him do it, but it's really not that necessary. I mean, these things, they're aluminum, they're gonna bend when you bolt them down. They flex. The original head, as it comes from BMW, it's actually kind of bent this way. So it's got a hump in the center, right? And the outside edges it's like this, like that. So when you bolt it down, this end, it's so that this end presses down more. And so what happens when you bolt it down is it kind of, this end comes up, that end comes up like that, and it kind of bolts down flat. There's that much flex in it, okay? You can actually, there's so much flex that you put a straight edge, you could actually rock it with the original heads. So there's flex when you bolt the thing down. That's why I'm not really concerned. It's gonna be just fine. People get away with this all the time. I think it's fine. Now, I elected not to get a valve job done because, that wasn't the original cause of the problems with this engine. We know that the problems with this engine was it overheated, it had that white stuff in it. It's not like it burned up a valve, it's not like any of that. And I can clearly, number one, I can see that there are no problems with the valves, no problems with the valves seating. And B, I poured water in the ports. All these ports, left it overnight, it didn't leak out. Did the same thing for the intake, poured water down the intake ports with it like this, water didn't leak out, okay? So no problems with the valves sealing. You could pull them out, I could clean them off, but I just, I don't really think it's necessary. You can do it if you want to be absolutely perfect. Obviously, if you're rebuilding your own engine, you're gonna have that desire. That's the desire I had when I did my first rebuild on my car. I wanted it to be all perfect, but I've done rebuilds since, and it doesn't need to be that. But you're only gonna get so much out of being that much more perfect, and you're never, ever gonna feel it. You're not gonna step on the gas and it's going to be that much quicker. It just doesn't happen. When you're doing a rebuild, you're not even going to notice the difference really. I had low compression that was towards the bottom of the service limit, 160 PSI. We raised that to 180. I didn't notice a thing behind the wheel. I mean, I thought I did, but as I've driven it over time, I realized there's no difference. So it's all about just, how perfect, it's just in the back of your mind. It's all about you knowing, oh, that's absolutely clean, when I put it back together. But you run it for a couple weeks and it's dirty again. So this is it. This is the head. And one thing that I do want to mention is that this head had, it had like that black sort of rubberized material from the gasket. That stuff kind of gets transferred onto the head. You got to clean that off if you elect not to get it resurfaced. If you're getting it resurfaced, you can leave it on. They cut the metal off, you know, so you don't have to worry about that. But if you don't get it resurfaced, you need to clean that off. And the way to clean it off is with steel wool. I used quadruple zero, the fine steel wool, and I used B12, Berryman's B12 Chem Tool. This, for me, this is the only way I can get the real lacquer thinner anymore that has toluene, methanol, and acetone in it. That's what you need. You especially need the toluene. The toluene just just gets it right off. So that's that. This is that black material that I was talking about. Just some of that black material stays on the head. So that's that, and what I'm going to do is we need to actually clean the block still. I didn't clean the block yet, so we still have that black stuff on it. So I'm going to go ahead, clean up the block. I'll show you what that looks like. And so this is what that looks like I was talking about. We just got to get that off, so all we do is use a little steel wool. So it's just like that. You just kind of do this. And that cleans it up. Now, you know, you're gonna get fuzz from the steel wool, and don't worry about that. You need to have compressed air though, because the compressed air will just blow all of that right out. So, you know, you don't really need to be worried about it getting everywhere. I'm not worried if little particles of steel wool get into the cooling channels right here, because that's sealed off. You know, it's just water that's recirculating constantly. Little tiny hairs of steel wool are not going to do anything to anything. So, you know, I'm not freaked out about that. But in the cylinders, you don't want them in the cylinders, so you got to blow all that out. But this is it. I'm just going to spend some time doing this, cleaning it up, and then we'll be ready to go. And that is what it looks like after it's been cleaned and blown out with compressed air. I also ran the steel wool around the rim right here just to kind of get the stuff off, you know, and clean those out. I turned the engine over a couple of times with a long ratchet just to kind of make sure nothing was in there, no trash was coming up along the sides of the cylinders. Everything's fine. I think what I'll do is I'll probably wipe a little swipe of oil in there just to make sure it's, you know, it's nice. And that's it. That's it. We can actually put this thing back on. Let's discuss how I'm going to put this head back on this thing. Now, it's one thing to kind of muscle it out, because you know you're not when you go to muscle it back in, you got to worry about scratching the new head or your resurfaced head if that's what you have, or just scratching your existing head. The problem is these right here. Actually, the problem is just the whole surface. It's way too easy to scratch that thing up if you're just kind of trying to lean over and put it down. If you're putting it back in with the exhaust manifolds attached, which I am planning to do. So we need to think about a two-stage process here. What I'm going to do is I'm going to put a piece of wood over the block right here. That way when I go to set the head down, I'm setting the head down on that piece of wood and it's not going to scratch anything. Then I'm going to use this, just like I used it to kind of pull the head out initially. I'm going to use it to set the head back on, especially because, you know, we have to get that alignment just right. You got to get the alignment of these little two alignment dowels just right in order for it to fit back on. In my previous rebuild video on this engine, I used little wooden dowels, which I'm going to do again. And that's what I'm going to do. So I saved the dowels from last time. They're 5/16 dowels. They're 6 inches long. And they go right in the hole. Right there and right there. We got a new L-ring gasket. Since I didn't have the head resurfaced, I just need the original size gasket. I don't need the thicker one. If you get your head resurfaced, I mean, it depends on how much they take off. I would say, you know, you've got about 13 thousandths, which is about 0.3 millimeters. So usually, like on my previous head when I had it resurfaced, it took about half of that. So it took about 0.15 millimeters, which is about 7 to 8 sixteenths, or 7 to 8 thousandths, excuse me. So, you know, that was kind of borderline. I did end up going with a thicker head gasket because I also had the block resurfaced, and overall it took out, you know, the thickness of the increased thickness of the thicker head gasket, which was 0.3 millimeters. So All in total, I had removed 0.3 millimeters between the block and the head. It made sense to use that thicker gasket. It made up the difference. If you're only getting your head resurfaced and they take about half that off, you can probably get away with using the original thickness head gasket. So, yeah. I do believe that L-Ring is the OEM manufacturer of the head gasket on these engines. At least that's what I've always understood. It might not be. Do your own research. Maybe it's Molly. But I used an L-Ring gasket on my last rebuild, and it came out just fine. Probably gonna have to pull that out just to get on here. Yeah. So I found a piece of wood that fits nicely. I put a little notch in it so that this end won't fall down, slip down like that. See, this end is being held up on that back there. And this little notch is just gonna hold it against the guide. So it's perfect. You know what? I think I'm gonna pull these out for now. It's gonna be just too difficult to put that head in and set it down on and get it aligned with these all at the same time. What I can do is I can get it on there. I can move it around and just sort of look down through the bolt hole and get this thing aligned and put it in there and then put it down, because the wood is up higher than the guide right here. So that head's just gonna be moving back and forth on top of the wood. And it's gonna be fine. That's not gonna mar the head up at all. Not good. So one issue is that this, I don't have the tires on the car right now, and I've got it up on jack stands. It's a little higher than it was originally. A little difficult to sort of get it up into place here. I'm definitely leaning over and straining a little. You know what? Okay, I've got it roughly in place. I'm gonna put the chain on now. That way I got the weight up, you know, and I don't have to kind of struggle with it. So that's a little better. At least I don't have to hold the weight of it. The issue is going to be getting my piece of safety wood out of there. So I think I'm gonna pull it out now. We don't really need it anymore. Okay, gasket's on. All right, I've gone ahead and lowered the exhaust. That's absolutely the best policy. It's super easy to do. There are only 4 exhaust hangers. There are 2 in the middle and 2 on the very end, at the end of the car. So now there's nothing obstructing me down below. I don't have to worry about any of that. I only have to worry about up here. So we'll just kind of get this thing somewhat low, sort of in place. Okay, might have made this chain a little too high. Yeah, that's it. Yeah, that's it. Kind of running out of thread here. We'll see where we get with this. Oh, okay, now we're good. I feel that we're sort of on. I believe that is it. Yeah. See, can't move it, can't rock it this way and that way. We're on our little alignment pegs. That's it. And there we go. Nice, easy way to lower the head on. No headaches. All right, so I've got my dowels pulled out of there, and I've got all the washers cleaned off and put back in place. These are the new head bolts that I have. Putting some oil on them. You just want to get oil across all the threads. Okay, you want them to be nice and oiled up. You don't want too much oil to be on there because it's a blind hole, you know, and oil doesn't compress. So if you put too much down in that hole, it's going to be a problem for you. If I haven't mentioned it before, you need to replace your head bolts. They are torque to yield fasteners. You can't reuse them. There's a chance that they could fracture. So yeah, you need to replace them. I'm just going to go ahead and run them down here. We're just cinching them up, making sure that they're just, you know, a little bit tight at first. That way when you go to torque them, you don't have a long way to go. The head gasket comes with instructions on the tightening sequence, 40 Newton meters, followed by 90 degrees, followed by another 90 degrees, which means 40 Newton meters starting at 1, 2, 3, 4, 5, 6. It's always the same with heads. You just kind of start in the center and work your way out. You do 40 Newton meters on all of them, start in the center, work your way out, then do another 90-degree turn, starting in the center, working your way out, and then another 90-degree turn, starting in the center and working your way out. Just because I said that the head bolts end up being around 60 foot-pounds doesn't mean that you should tighten them down to 60 foot-pounds. That is not the right way to do it. This is the way that you need to do it. Because what happens is they all end up being a little different variation on that. And you want to make sure that they don't loosen up. So do it the way that I just said. So everything torqued down perfectly. When I did the first 90-degree turn, most of them were reading, this torque wrench has the ability to tell the maximum torque that it reached each time it does a 90-degree. So the first time around, everything came out to about 54 or 55. The second 90-degree, they also came out to 54 or 55. The tension was, it did increase just a little bit on the second 90, but not so much that you could really feel it. But I mean, the tension was there. It was really hard to do the final 90, so nothing pulled out. But this just kind of illustrates why people seem to have problems. You know, they torque them down to 60 foot-pounds or something. They think that that's the proper torque, and it's just not. You need to do that 90 and that second 90. You're not really increasing the torque that much, but I guess you are increasing the clamping load. You know, you're spreading it out over more threads or something like that. I don't know. I don't really know all the science behind it, but you got to do it this way. Otherwise, you have problems.